Hey everyone, here's a video on how to graph square root functions. So let's start with the basics. Let's start with y equals the square root of x. And we're going to choose some x values and see what y values they produce. So if we choose 0 and we plug it in here, we get y equals the square root of 0. And the square root of 0 is just 0. If we choose 1 and we plug 1 in there, then we get y is equal to the square root of 1, and the square root of 1 is 1. If we choose 2 and we plug it in here, then the square root of 2 is not going to be an even integer, it's going to be a decimal, which is 1.4 and change. Same thing for 3. If we plug it in, we get 1.7 and change, but we can take the square root of 4. We can't really take the square root of 5, it'll be another decimal. Let's get all the way to 9, we can take the square root of 9. So what that allows us to do then is to go in and graph those points. We have the point 0, 0, we have the point 1, 0, 1, 1 I mean, and then 1, 2, 3, 4, this is 4, and then 2, we have the point 4, comma 2. So it goes really steep and then it flattens out. And then all the way at 9, we get up to 3. Okay, so that's the basic square root function. Now we can modify that a bit with something like this. Y is equal to the square root of x plus 1. What that's going to do is it's going to allow us to move things around a little bit. So let's try some values. Now if I try, let's try 0, for example. If I plug in 0, then I get the square root of 0 plus 1, and the square root of 0 plus 1 is 1, and so I get 1. Okay, let's try 2. Or sorry, let's try 1. If I plug 1 in here, let me erase this, If I plug 1 in there, then 1 plus 1 is 2, and then the square root of 2 is going to be 1.4. Let's try 2. If I plug a 2 in here, then I get 2 plus 1 is 3. I get 1.7. Let's plug a 3 in there. If I do a 3 in there, then I get 3 plus 1 is 4. Square root of 4 is 2. And I can actually plug in a negative 1. Let's go ahead and do that. Negative 1, when I plug it in, is going to do what? Negative 1 plus 1 is 0. Square root of 0 is 0. And I can't go any further to the left of negative 1, because if I do that, I would have to take the square root of a negative. So when I graph this one, it's going to look like this. We've got negative 1 that goes to 0. So this is negative 1, and we have the point negative 1, 0. 0 is going to go to 1. And then we have 1, which is going to go to 1.4, 2, which is going to go to 1.7, and 3, which is going to go to 2. So you have the same kind of thing like that. Now, if you compare that with our graph of the original function, this is our original. What happened with the new one is it moved it to the left. And that plus 1 right there ends up shifting it to the left by 1. Let's do another example. Y equals the square root of x plus 1. X and y. I'm just going to choose easy values like 0, 1, 4, 9, and 16. If I choose 0 and I plug it in there, then the square root of 0 plus 1, that's going to be 0 plus 1, I get 1. If I plug 1 in, then I get 1. Square root of 1 is 1. 1 plus 1 is 2. If I do 4, square root of 4 is 2. 2 plus 1 is 3. If I do 9, square root of 9 is 3. 3 plus 1 is 4. And if I do 16, square root of 16 is 4. 4 plus 1 is 5. So when I graph it, how is that different? Well, if this is my original function, then this new one, everything gets raised 1 higher. So it goes like this. So what that plus 1 outside of the square root does, what that does is it lifts it up by 1 units. Okay, so the pattern here is this. If I have the square root of x minus 2 plus 3, what that minus 2 is going to do is it's going to shift it to the right by 2. What that plus 3 is going to do is it's going to move it up by 3. So let's do this on our original graph. Our original graph would look like this, but our new graph is going to be shifted to the right by 2 units. So this point gets shifted to the right by 2 and up by 3. So now it's going to start here. So if X marks the spot there, X marks the start right there, and the new graph is going to look like that. So it's going to be transformed. Let's do this in Desmos so you can see what this looks like in real life. So let's do the square root of x. So this is our parent function, square root of x. Everything else is going to be a modification of that. So if we do the square root of x, and if we do a minus 1, you can see that the minus 1 moves it to the right. Let's go and do another one. If I do the square root of x plus 1, then you can see that plus 1 moves it to the left. And that's a little bit counterintuitive because plus we usually think of moving to the right, but under the square root, that plus 1 is going to move it to the left. All right, let's do another one. Let's do the square root of x, but we tap over here, we're going to do a plus 1 outside of it. Well, you can see that from the red to the purple, it got raised up by 1 unit. And if for the same reason, if we do the square root of x minus 1, it's going to drop it down 1 unit. Okay, now we can combine these together into something like this. The square root of x minus 2. I'm going to hide this for a second, and we're going to predict where the vertex is going to be, plus 3. Okay, so the red one's our original graph. What that minus 2 under the square root does is it moves it to the right by 2. That plus 3 is going to move it up 3. So hopefully you can guess where the new vertex is going to be. We're going to tap on this, and there we go. Is that what you predicted? Good. It moved it, let me shrink this down. It moved it to the right by 2 units, and it moved it up by 3. Okay, let's do another one. Let's predict this one. Let's do the square root of x plus 1, hide that, minus 2. Okay, so predict where this new graph is going to have its starting point. And let's see if you're right. And yep, that plus 1 moved it to the left 1, that minus 2 moved it down 2. Okay, there's a couple other bells and whistles we're going to talk about here. One thing we can do that we haven't done yet is we can make it steeper and grow faster. So that's the square root of x. If I put a number in front like 2, or going bigger, if I do 3 or 9, it makes it steeper and steeper and steeper. So I'm going to put a letter here. Let's just choose the letter A. We're going to add a slider, and you can see as I move this slider, it gets steeper and less steep. Now if it goes negative, it's going to flip it completely upside down. We'll talk about that in a minute. But for now, just remember that A controls the steepness of that graph. Okay. So we can do something like this. We can combine things together. We can do the square root. So we can do the square root of x minus 2. That moves it to the right 2. And then outside of the square root, we're going to do plus 1. And then we can change the steepness here. We can put a 2 there. So moved it to the right, made it steeper. We can do 3. We can do 0.1 if we want to make it flatter. And that just controls how steeply it grows. Okay, the last thing we need to talk about is our reflections. Now we talked about it a little bit here when we do this negative the square root of x. And that's going to flip it upside down. And you can combine this with a number or whatever, but that's the idea. Negative reflects it across the x-axis. Let me change my colors here. Let's make that purple. Okay. Now, what happens if you put the negative inside the square root? If I put this inside, that's going to reflect it that way. So the negative under the square root reflects it across that way. Okay, what if we reflect it both ways? If I put a negative on both sides? Well, the negatives don't really cancel out. Instead, it reflects it first across the x-axis and then across the y-axis, and so it double flips it and puts it kind of opposite there. Okay, I think that's all you need to know. Let's just review one more time here on the notes. So let's say you have something like this, and this is 1, 2, 3, and you have a graph that looks like this. When you write the equation for this, you're going to use the fact that the starting point is 1, 2. So we're going to do y is equal to the square root. That 1 means it got shifted to the right by 1. So we're going to do x minus 1. That 2 as the starting point, that 2 means that it got raised up by 2. And so we're going to do a plus 2. Now, if it was really steep like this, you'd have to check, and maybe you'd put a 2 in there or a 3, depending on how steep it is. But one way to check that steepness is this. If here, from here to here, I go over 1 and then up 1. So if I go over 1 and up 1 at my initial points, then that steepness is going to still stay a 1. So there's no stretch factor. But if it was something like this, if it was over 1 and up 2, and my graph looks like that, then the blue one would be y equals 2 square root of x minus 1 plus 2. Okay, let's see if we can identify this one. Here's the graph. Y equals the square root of x. What would the equation of this be? And that would be y equals the square root of negative x. Okay, the negative x under the square root reflects it across the y-axis. Okay, what about this? What if I have the original graph, and if I did this, then that would be y equals negative square roots of x. So the negative in front of it is going to flip all of these nice positive values down to negative values. Okay, I think that's everything you need to know to graph square root functions.